In example 4, we saw that if we switch the x and y values of ordered pairs on a function, we'll get corresponding ordered pairs on its inverse function. So that means if we switch the domain and range of a function, we'll get the domain and range of its inverse function. So we can say that the domain of a function f will be equal to the range of its inverse function, and the range of a function f will be equal to the domain of its inverse function. We also saw in example 4 that if we graph a function and its inverse, we will observe symmetry about the line y equals x. So a function and its inverse are symmetric about the line y equals x. Now, in your homework questions, when you're asked to find inverse functions, they're going to tell you that the function they give you is a one-to-one function. That's because if a function is one-to-one, then it will have an inverse function. On the other hand, if it's not one-to-one, it doesn't have an inverse function. So here's an example. If we think of a function that's not one-to-one, that would be a function that fails the horizontal line test. So if we think of a graph that would fail the horizontal line test, let's think of a parabola opening up, for instance. So we know that would fail the horizontal line test. So this is not a one-to-one function. Okay, so if we reflect this graph about the line y equals x, if we reflect it, you can see it's actually going to turn that parabola on its side, and it's going to be a parabola opening to the right. Well, if we have a parabola opening to the right, if that were its inverse, that would fail the vertical line test. So this wouldn't even be a function. So that's why in all the problems that you'll do in your homework, it'll say find an inverse of a function, and they'll tell you that the function they give you is one-to-one.